Good morning, afternoon, or evening to you wherever you are. I'm Arsalan Arif with Endpoints News. Our topic today is an introduction to self-service DNA encoded libraries, or DELLs. We're sponsored by Wuxi AppTech, and it's my pleasure to introduce our expert today, Alex Satz. Alex has 15 plus years experience building DNA encoded library platforms and is currently the Senior Director of Dell Strategy and Operations at Wuxi AppTech. Prior to Wuxi AppTech, Alex led the Roche Dell platform in Basel and helped to develop the first industrial scale Dell platform at Praxis Pharmaceuticals and GlaxoSmithKline. Alex has an approximately 30-minute presentation today, and we'll follow it up with some questions. Hit that Q&A button at the bottom of your screen to get them in live, and if you're watching on demand, someone will follow up with you by email. And now, without further ado, I bring you Alex Satz. Alex, take it away.
Hey, thank you very much for the introduction. Yeah, my name is Alex Satz, and I've been working in the Dell field for about 15 years now. And today I'm going to talk to you about the Wuxi Dell platform. In particular, I'm going to focus on our self-service Dells, the Delight Kit and the Dell Open Kit, and I will tell you about how they work and how you can get them. Let's see. So first of all, the Wuxi Dell screening platform is part of a larger team. It's called the HITS team, and we are focused on early stage drug discovery. So that means that we do everything from producing protein to doing binding-based screens, biophysics, so that when we get a hit, we can follow it up and determine how well it binds to the protein target. And of course, if you want to do med chem, it's often best to get a crystal structure of your hit bound to your target. And for that reason, we do crystal structures too. But today, what I'm going to focus on is the screening part, in particular, my area of expertise, which is Dell screening. Right, so our main screening site is in Shanghai, but I do want to stress that we can also do screens in Boston and in Munich as well. Additionally, at our Munich site, that is where we do protein production, fragment-based screens, crystallography, and biophysics, although we can also do some biophysics in Shanghai as well. So here, what I've done is I've plotted the number of papers that have been published each year using the PubChem search term of Dell. And what we can see here is that if you go back about 10 years, there was very little work which was being done in the Dell field. And as someone who started in the Dell field in perhaps 2005, I can confirm that this plot is telling us the truth. There were very few Dell screens being done if you go back just a few years. But today, almost every big pharma runs Dell screens in order to find hits against their targets. This is something which has been true for the last few years now. Dell is also more commonly worked on in the academic field as well, which has certainly helped the technology get a little bit better. It's common asked, well, what kinds of targets can you screen with Dell? And so I provided a few examples shown here from these citations. And you can also see the variety of different structures of the hits that come from these screens. So this gives you a sense for, can Dell screen many different target classes? The answer is yes. And will it provide chemical matter that looks like drugs? And again, the answer is yes. And this is something that we'll talk a bit about more in a later slide. So I wanted to tell you about how we at Wuxi, how we make these Dells and how we screen the Dells. And I think to do that, I first have to show you what a library member actually looks like. So here I show this very simple structure here. So if you read off the barcode, if you read the sequence of it, the sequence is going to tell you what the structure is that is attached to it through this long flexible tether. Okay, so how are these Dells made? And the key is that they're made through split and pool combi-chem. So just as a for instance, let's say we had a mixture of three things as shown here, And each of the sequences of the barcode tells us what the structure is that is attached to it. So we have a mix of three things here, three different barcodes and three different structures. We aliquot this mixture into three new tubes. So this is the split part of split and pool. Oops. And so now we have three tubes, a split size of three, and in each one of these tubes is these three things. And now into each tube, a new BB is added with a new tag. And the tag is added here in each case, and the chemical structure is elongated here, here, and here. And so in the end, what we end up with are 9 new structures. Each structure is encoded by its barcode, and we can now pool these into a single tube. And so we've done the split part here, and now we take these 9 structures and we pool them, and that is essentially split and pool CombiChem. Now, when we make Dells, though, we don't use split sizes of 3. Instead, we might use split sizes of 96. So in this case, we do 4 cycles of split and pool CombiChem, each one having a split size of 96, and we make 85 million new structures. Or we could use a split size of 9,000, and we could use 2 cycles of split and pool, and again, we make about 80 million new structures. And so in this way, we can make a lot of new structures in a very efficient and rather cheap manner. This means that since screening is usually a numbers game, Dell does very well at this game because it makes a lot of structures in a fairly inexpensive manner. So after we make all of those Dells, so let's say we've made 50 Dells over the last 24 months, we can combine them all into a single tube. And so this is what our Delight Kit is. We have 4 different tubes, and each one of those tubes are billions of different structures, and each of these tubes contains essentially an identical copy of all those billions of different structures, which means that you can screen your target or multiple targets using a single kit. So how is the Dell screen actually done using these tubes? So you take your target and you immobilize it onto a solid phase resin, and you then take the Dell from the tube. So you take the Dell straight from one of these tubes and you add it here to your target, and you wash away everything that wasn't bound. And of course, most things don't have a chemical structure which is capable of interacting with the binding pocket of your protein target. However, a few things do. A few things are a correct match, and we capture these and we amplify the barcode, we sequence the barcode, and from that sequence, we can tell what the chemical structure was that was bound to the binding pocket of your target. So in the end, after these screens are done, what do you get out? And here I list a few examples of published cases where pharma has run a screen. So the target is shown here. They've run a screen. They found a hit directly from the Dell screen, and those structures are shown here. They then did medchem in order to optimize this hit, in order to usually to make it more potent. And the structures of the optimized hits are shown here. And then the status, where did this optimized hit end up? That is shown here. So in this case for WIP1 or for SCH, it ended up in phase 1 or phase 2. In the case of DDR1, we ended up with an in vivo probe. And in the case of BET, we ended up with something close to going into phase 0 or phase 1. So I think if you're in the academic world, you can look at results such as this, and you can think, well, that's great because we have a target that we would like to screen. We would like to find a hit, which we could then do medchem on and discover a drug which could go into phase 1. But the problem is that you probably don't have access to a large pharma Dell platform that you could use for this screen. And that problem was talked about by Richard Lerner in this paper cited here. where they discussed how academics have targets, but they can't necessarily run the screens that they need to run in order to publish papers or to find drugs. And so we have teamed up with them in order to create dellopen.org. And you can go to this website and you can find out about how all of the Dell Open works. And I'm going to talk to you about this soon, but this is a way for academic groups to be able to get a Dell screening kit and to run their screen, and it is essentially completely free. So how does Whooshi work here regarding its Dell platform? So we have a few different options. The first is the one that I'm not really going to talk about too much today, and that is where you send a target to us and we use our expertise to screen it. We look at the data and we work with you to find the best hits. And of course, this is the best way to find a drug-like hit. However, there are cases where a company might not want to share its target with us. And so we offered a Delight version. So this is a Delight self-serve kit. So in this way, we send a Delight kit to you. You run the screen in your labs, and that way we at Whooshi, we never actually know what the target was that you screened. You then take the wet samples from that screen and you send it back to us, and then we work up the data, we share the results of the data with you, and you can decide if the data looks good, and if it does look good, you can pay an additional fee, and then we can unblind all of the structures. The third option is the Dell Open Kit. This is for academic groups, and what's great about this kit, as I said, is that for an academic user, it's completely free. You request the kit from us, we ship it to you. You run the screen in your lab, and again, you send the wet samples back to us. So we'll talk a little bit more about how the workflow of Dell Open works. Okay, so the first thing that you have to do as a researcher is to request the kit from us, and then the kit is shipped to you. So you just go to the Dell Open webpage, you put in your name and some other things, and then we ship the kit to you. You physically have to conduct the screen. It's not that bad though. There's some directions for the screen shown here. We have a video that's about 15 minutes long, and it actually shows you step by step how to actually conduct this screen. Now, when the screen is done, you will then send the samples back to us. And when the samples are back with us, we do the PCR, the QC, we decode it all, and then we generate a report which shows you the enrichment signals against the target that you have screened. What we don't show you, though, are the physical structures. So the structures are still blinded to you. Now, from the results of those screens, you decide which hits you would like to synthesize. And these hits are synthesized by us at Whooshi, and then they are sent to you as a solid powder. But again, these structures are still blinded to you. You then test them, and if they're active in the assays which you have, then you have two choices to unblind those structures. So the first is data for hits. So this is called Dell Open. It's run by an academic group, and the goal here is to make things as open as they could be. And so you decide to share metadata from your screen. You share the name of your target, and in exchange, the structures of the hits are unblinded, and that is completely free. And from that point on, you are free to attempt to patent those hits. You could sell the hits, you could create a startup, you could publish a paper, whatever it is that you would like to do, you are free to work on those hits. They are completely owned by you, and there are no strings attached to us at Whooshi. The other option is you might decide that the value of these hits potentially is too high, and you might not want to share your target name or any of the metadata associated with the target. In that case, you can pay Whooshi a fee, and then we could unblind the hits, share those structures with you. Again, those structures are completely owned by you. There's no strings attached to us. However, in this case, because you've paid the fee, you don't need to share the target name with the Dell Open website. So the reason why we want to have, however, the metadata and the target name shared with the Dell Open website is because then other academic groups could look at this data and then they could decide that their interest level in it is rather high and they could send you a note since you're the owner of this data and they could ask if they could work on your target with you. And if you agree, then this other academic group could then have 5 more structures unblinded for them. And of course, if they have more structures, they could do more assays, publish more papers. And of course, that is the goal of Dell Open, is to share this data and to get it out so that more and more scientific work can be done. So in addition to Dell Light, in addition to the Dell Open, we also have the Delight Kit. And I'll quickly go through what the workflow is for that. So let's say that you want to screen a target, but you don't want to share its target name with us at Wooshi. You can instead order the Delight Kit from us. It gets shipped to you. And then again, you run this physical screen in your lab. You take the wet samples resulting from that screen, put them on dry ice, you ship them back to us, and then we do the amplification, the QC, and the informatics. We then share a report with you where the structures are blinded, but from this, you can decide if you want to pay the additional fee to unblind the entire data set. And the entire data set is everything that enriched from that screen against every Dell. The data set is usually tens of thousands of structures long, so it's a very large data set. And after that is paid for, you are completely free to work on everything within that data set. Of course, I should point out that you get what you screen for. So even though the Dell Open Kit is free, bear in mind that if you screen protein that isn't pure or that has other problems, then chances are if garbage goes into this screen, that garbage could come out the other side. Now, of course, with that said, I've been screening Dell targets for 15 years, and I can say that a few times we have screened targets which weren't in great shape or targets which weren't terribly stable, and yet the screen still worked and we were able to find hits. But with that said, if the quality of the protein drops, the risk of the output of the screen not being good goes up. So I've talked a bit about how in both the Dell Light and the Dell Open case, you're going to be sent a summary of how the screen went, but the structures won't actually be shown. And based upon that, in the Dell Open case, you're going to choose hits to resynthesize. In the case of the Dell Light, you need to choose if you want to pay this fee to unblind all those structures. And so I thought it might be useful to give you an exemplar case of what the report looks like. We don't do internal screens here at Wooshi, but in this case, we did do just a single test case so that we would have some data to show you. So here we've run a screen against a target, which is in columns 1 and in column 2. And then in column 3 and 4 is where nothing is being added. So this is the NTC, it's the background signal. And what we're trying to find here are hits that enrich in both columns 1 and in columns 2. So that's column 1 and column 2, and the overlap is what we're calling region A. So we're looking for things that enrich in both of these, but do not show up in columns 3 and in columns 4. So the first thing that we at Wooshi do when we get the samples back from you is we do qPCR in order to QC those samples and make sure that they look good. So just as if, for instance, we want to make sure that the right amount of Dell is coming out of each one of these different steps of the screen. If there's a major problem here, we can alert you to it. In the case of Dell Open, you might need to run the screen again. In the case of Delight, you would know that you don't want to buy the data package. Now, as far as how this data is going to be shown to you, we use these line plots, and an exemplar is shown here. So for instance, this is Dell number 139, and each line represents a specific structure that is showing up in this screen. The enrichment level is shown here on the y-axis, and on the x-axis are the different conditions. So for instance, here we have something which is enriched against the target in condition 1. It's more enriched in the target in condition 2, but when the target isn't present in conditions 3 and 4, we see that the enrichment is extremely low or non-existent, which is what we would like to see. As a very general rule, we would like to see the enrichments above the 100-fold level. And so we would consider this one hit here to have a good chance of being like a real solid hit, whereas these others are a little bit more questionable. All right, so this is a very complex plot here. We see every single one of the 50 Dells that exist in the Delight kit. And in each one of these Dells, we see the different structures that have enriched above a certain threshold. And all of these belong to group A, which have enriched in both condition 1 and in condition 2. And we find that there are almost 25,000 enriched hits. However, we then subtract out the NTC. So now we're only looking for things that exist in this condition A. And we now have 3,400 hits left. And we can see for each Dell how many hits are showing up. We're then going to zoom in further, and we're going to look at, well, we said that we would like the enrichment to be above a cutoff of 100. Let's just look at those, and we find that there are 14 different hits enriching above that level. For instance, we have things from Dell 49, and we have the generic scheme for that Dell shown here. And we also have things from Dell 69, and the generic scheme for that Dell is shown here. But let's zoom in just a little bit further, and or actually let's zoom back out, and we can summarize this, and we can say that we have 14 hits in region A, where the enrichment is above the threshold that we would like, and that these are the top Dells. And from that point, if you were in the Dell Open screening kit, you would need to go back here, and you would need to choose which hits you would like to make and then test to find out if they're active in the assays. And if this was a Delight kit, you would need to decide if you wanted to pay the fee in order to unblind all 3,400 hits, or at least that. Okay, so with that said, just for this example, let's go ahead and see, what did these structures look like from Dell 49? So there are 6 blue lines shown here, 6 different structures corresponding to this Dell. And this building block at cycle 2 corresponds to this one shown here. And we have a variety of different BBs which exist at cycle 3. And when we combine these to make the final structures, those 6 different structures are shown here. As you can see, there's a bit of SAR, and you get a sense for what active hits are going to look like against this protein binding pocket. In this case, we resynthesized all of these hits with their barcode attached, and then we test them for binding in an AFSEC assay. We don't get KDs from this, but we do have binding confirmed for all 6 of these hits from this particular cluster. Okay, so with that said, I want to introduce you to at least the management part of the Wuxi Dell team. We are a group of almost 200 people. The management team is shown here, including those in charge of our clients. And then we have the scientific management on this slide. This is myself shown here in the bottom left. That matters. And I will leave you with a list of the services which we can provide from the Wuxi Hits team. And as I said, I believe on the very first slide, that covers everything from producing protein to doing at least binding-based screens, such as Dell and fragment-based screens. Of course, we can do the biophysical follow-up work in order to make sure that those hits are real. And then we can do crystal structures in order to enable later medchem work. We can also do structure-based, fragment-based screening too. Okay, so with that, I'm done. I'm not exactly sure how long that took. Yeah, about 30 minutes, and I am open for Q&A.
All right, thank you very much, Alex. Appreciate that. I want to remind the audience that now is the time for questions. You can hit that Q&A button right down there, and I'm going to get them to Alex. We've got already a couple over here. I've grouped some of the questions for you, Alex. I'm going to start with one over here from the audience. How compatible is Dell screening with DNA binding proteins or assays where one condition might be the protein DNA complex?
Uh, so, so we run a lot of screens against proteins which either are known to bind DNA or which in the end we figure out they do this. Um, So the first thing that we do is we test to find out if this protein is going to bind the barcode that we use. And if it does, we need to block that protein binding pocket. And we block it by figuring out what the sequence is that the protein binds to, and we simply add a large amount of it to it. Um, the only bad part of that plan is that if you want to find a ligand which is going to bind to the protein DNA binding interface, if you block that binding pocket, then you can find something that binds to it. But usually that isn't an issue because that DNA binding interface usually isn't a very good binding pocket anyways.
Okay. All right. Now, can you tell us what kind of proteins cannot be screened by DELs?
Um, So proteins that aren't stable or that we can't get in some sort of a purified form, then we can't screen. Everything else is completely possible. Even targets which you would consider to be, like GPCRs, ion channels, things along those lines. You can always screen them, but the problem isn't conducting the Dell screen. The problem is producing those in a nice, pure fashion where they are actually I have a bit of a stutter here. If I can get this word out here. If they're not stable, then we can't screen them.
Very good. Very good. Okay. If they're not stable, then we can screen them. All right. So, how many different types of DELs, types of reactions, are in the light set? Here's a question that we have.
Oh, right. So Delight has 50 Dells in it, and then Dell Open has 30 Dells. But we do constantly upgrade these kits. So that's a number where if you were to come back and screen Dell Open in 6 months, then the collection might be larger.
Okay. So, what's the difference between the molecule in Delight versus Del Open?
Yeah, so they contain different Dells and they're completely different Dells. So in theory, the structures in each one of those, there won't be any overlap between those two. Academic groups tend to have a higher interest in peptides and perhaps some structures that are a little bit less drug-like. So we tend to move those into Dell Open, whereas Delight, it tends to be much more focused on startups. And certainly they like to more screen in the drug-like space. So I would say that Delight is more veered towards drug-like space and Dell Open is more veered towards the peptide space, but they both contain a bit of both.
Okay. All right. Here's some questions we have. I'll group them together. Speaking to the overall success rates of a Dell screen, can you speak to the overall success rate of these Dell screens?
Yeah, so So we occasionally we run an internal test, and we find that as long as the protein is indeed clean and it's pure and it has a normal binding pocket, we always find hits. Um, but what's going to affect your success rate is, are these proteins pure, and do these proteins actually have a binding pocket that the ligands can interact with? So if your targets are really, really tough, some of them won't find hits. But if your target has a nice binding pocket, then I think you're pretty much assured of finding something.
Okay. All right. I think I've got one last question for you here, Alex. But before I get to that, I want to let the audience know that we will be following up with all the registrants, everyone who watched, with a link to today's presentation and information on how to contact the Wuxi team. Alex, one of your slides did have how to contact you guys, or a link to follow up with. That was in a previous slide. Perhaps I just want to let the audience know about that again before we get to our last question here. How does Wuxi make money from Dell Open? I don't get it. Here's the exact question. How does
Okay.
Wuxi make money from Dell Open, Alex?
Yeah, so I don't think we do. So Dell Open is a separate organization, and it's overseen by this academic group. With that said, Wuxi plays a role in this because what Wuxi would like is for academics to find hits. And then, of course, getting papers is great, but what we would like to see even more is perhaps a startup that would result from that work. And if you started up a company, you would probably need services that Wuxi provided downstream, and perhaps you would come back to us. So that's sort of the long-term goal there. And yeah, you raised a good point of, I used to have a slide with our email on it, but I'm not sure I do at the moment. Right.
It's no problem. We're going to make sure to follow up with the entire audience with an email.
Perfect.
We'll have no problems getting in touch with Wuxi over there. I just wanted to point that out. But Alex, I want to thank you for that very thorough presentation. With that, we're going to conclude today's webinar. I want to thank you to Wuxi AppTech again, and also to you, Alex Satz, for sharing your expertise with us today. For Endpoints News, I'm Arslan Arif. Thanks for joining us, and we will see you next time. Thanks again.